Welcome, I'm David Fuentes from the University of Alcalá. Today I will present the tutorial LED visualization using Charlieplexing as part of the work of Ruby team partner from the University of Alcalá in the Erasmus Plus project HEMS. Today I will guide you through the concept of the fundamentals of Charlieplexing, how we will apply it, and a real example using Arduino platform. This lecture is structured as follows. First, we will discuss the objectives of the course. Next, we will introduce the basic concepts of Charlieplexing, including its definition and underlying tri-state logic. Then, we will explore a practical example illustrating LED visualization and time representation through Charlieplexing. Finally, we will conclude with the key takeaways and further reference. Let us begin with the objectives. The primary aim of this tutorial is to develop and understand Charlieplexing codification. You will learn how to control a large number of LEDs with a minimal number of microcontrollers outputs using three-state logic inherent in modern microcontrollers. Additionally, you will see how this technique can be implemented in Arduino environment. Now let's explore the basic concepts of Charlieplexing. Charlieplexing, also known as three-state multiplexing, is a method that enables the control of many I/O devices, like LEDs, using only a few I/O pins. The key lies in the ability to set each pin in one of three states, which when combined allow for multiple unique configurations. For instance, with just 3 pins, we can potentially control up to 6 LEDs. In the next figures, we see an example configuration using 6 LEDs. Notice how the pins are dynamically set to output high, low, or left as input, thus activating a specific LED while keeping the others off. This efficient use of hardware resources is one of the major advantages of Charlieplexing. Although our main focus today is on Ruby board, Charlieplexing can be also implemented in Ruby board through the use of Arduino IDE. In Ruby board, 6 LEDs are arranged in a specific order, which is D3, D5, D7, D4, D6, and D8, and 3 microcontroller outputs are used to control them. The configuration is achieved by setting the pin modes approximately using functions such as pin mode to designate outputs or inputs. Moving on to the visualization example, our objective is to implement a descending timer of 20 seconds. The idea is to use Charlieplexing to represent the remaining time visually on a set of LEDs. This is done by quantizing the total time into discrete levels, where each level corresponds to a specific LED configuration. The resulting pattern is displayed via serial output on the Arduino serial plotter. Let's break down the code that makes this possible. In the initialization phase, we define essential constants and variables such as LED pins, which hold the digital pins assigned for the Charlieplexing outputs, max time that defines the full duration of the timing, LED levels, which indicates the number of visual levels, and time step, which is the duration associated with each level. These parameters ensure that our time quantization is both precise and adaptable to other cases, for example, other boards. In the setup function, the serial communication is initialized at 9600 bauds, and all Charlieplexing pins are configured as outputs. This step ensures that the system is properly prepared to control the LED states as soon as the timer starts. Within the main loop, the elapsed time is continuously retrieved using the mylist function. The level display function then maps the current time to a corresponding LED pattern. It does so by determining in which time interval the current value lies and accordingly calls the Charlieplexing function with the specific parameters. The Charlieplexing and level display functions are critical. They configure each of the 3 designated pins to either output or input based on the required pattern. Then, using conditional checks, it sets the appropriate logic levels to display the desired LED state. This selective control forms the basis of the entire visualization process. In this slide, we propose you to create a descending timer of 20 seconds that shows the remaining time through 2 different ways. The first one is by the use of the serial plotter or print, and the second one is using the Charlieplexing to show in binary the remaining time. Remember, in the later case, that LED's position are D3, D5, D7, D4, D6, and D8 in the Ruby board. Before we conclude, let's recap the key points of the lecture. We have examined the underlying principles of tripleXing, understood its application through practical code examples, and seen how it can be used to create dynamic visualizations on an Arduino platform. We additionally learned how to use the alternative representations like binary ones, and finally learned how to use the counters and timers to control the timing of the software developed. This approach not only maximizes hardware efficiency, but also opens new possibilities for creative LED displays in embedded systems. Thank you for your attention, and if you have any questions or need further clarifications, please refer to the reference provided in the presentation. We encourage you to experiment with tripleXing in your own projects and explore its potential in various applications.